Okay, the time now is 7 p.m. The time now is 7 p.m. I'm starting the lesson. You're here because you are the lower secondary, probably Sec 1 or Sec 2. If you are Sec 3 and Sec 4, you are welcome to join this class also because it's a good revision. Understand that if you are in Sec 4, right, whatever that's been covered in Sec 1 to Sec 3, right, will be tested in your Sec 4 exams also. All right, so it's very important for you to lay your foundation strong. So for the Sec 1 and Sec 2, just to let you know, yes, all these topics will eventually be what? Be covered again in your O levels when you're in Sec 4. All right, so it's better to learn it once properly, right? So if you can learn it once properly, you make sure that the foundation is strong, you keep it in your head, you know totally how to do. Next time, whatever that builds on, right, will be easier. All right, it's just like building a house. All right, you must lay the foundation first before you can build higher. Can? All right, so what do I need for this lesson? Okay, I will need the notebook or the exercise book, some paper for you to do your rough working lah. I prefer exercise book because everything is in a book, so it will not be very flimsy. You know, sometimes people get lost in all this, correct? Okay, the next thing I need is your worksheet. All right, if you have the worksheet, it will be great. You can actually do the steps. You can actually do the workings along with me inside the worksheet. So you got something to refer to. That will be great. If you don't have, don't worry. You can go and download it later. Can? Next is your stationery. All right, if you have colored pens, that'll be good also because I love to see more colors everywhere. All right, colors actually brings up the question. It makes it a little bit more exciting. And next one is your calculator, as I say. All right, try to have your calculator with you. So later, I want you to practice pressing certain things with me. All right, I'm going to teach you something which is going to be not taught in school. All right, not taught in school, but the teacher sometimes will ask you question related to it. And it's very hard to get a solution out of it. Okay, for me, I love math. Why? Because of the formulas. All right, so there's always a formula to the question. So for example, how do you find the area of triangle? Bam, half time base times height. Very straightforward. All you got to do is to exchange the base for a number, exchange for the height for a number, and you can get a number out from it. Can you see now? So it's a lot of questions, right? In math is based on formulas. Once you get the formulas out, you know how to use it. Bam, the question is yours. You will own it. Okay. So moving forward, I will need your attention and focus also. All right, this lesson will be about 1 hour to maybe 1 hour, 10 minutes like that. We see how it goes. Can? All right. So number pattern, right? Usually the question, right? Actually, number pattern is part of the algebra, right? Yep, for the Sec 1. Then some of you are say Sec 2. Sec 2, this number pattern is not taught in Sec 2. No, no, no. All right, if you're in Sec 2, number patterns are taught in Sec 1. And during your mid-year exam, if you have, or maybe your final year, you know, those exam, right, those weighted assessment, right, sometimes they will bring out the number patterns one. All right, you cannot just say that, okay, whatever that is learned in Sec 1, I will forget. Sec 2 got Sec 2's topic. Nope, nope, nope. All right, if you're Sec 2, you must know your Sec 2 and your Sec 1 topics. Okay, so it's very important to remember some of these formulas so that when it comes out, it's easier to use it, easy to activate it. Can? And for number pattern, they always look for something called the end term. Looking for something called the end term. All right, so what is the end term? Later, I'll explain a little bit further. Can? Okay, so moving forward, let's jump to something simple. It's a very simple exercise down here. All right, what is this? This one, right, you can see that the numbers are actually what? Decreasing. Okay, so you have 2,187, 729, space 81 and 27. Okay, so sometimes, right, something called number pattern, right, I will always think of certain things, you know. Number patterns, right, I will always think of certain things. All right, actually, there's a few category lah. Okay, the very first category, right, is what I call the what? The perfect category. It's perfect. Okay, what's perfect? So when we talk about perfect, we talk about something called perfect square and something called perfect cube. Do you know what's that? Right. What are examples of a perfect square? All right. Perfect square means what? Example, you must know this. Perfect square can be equal to 1. Huh? 1 is a perfect square. Is it? What's the next one? 4. Then what's the next one? 9. Then what's the next one? 16. 25. All these very familiar. All right, all these very familiar. All these are considered perfect square numbers. Correct. How do I get the perfect square? It's like 1. 1 times 1 is a 1. That's why 1 is a perfect square. 2 times 2 is a 4. 4 is a perfect square. 3 times 3 is a 9. 4, 4, 16, 5, 5, 25, 6, 6, 36, 6, 7, 7, 49, and so on. All these are what I call perfect square numbers. So you recognize them. Recognize them. When you see them, right? Perfect square numbers. Another one is your perfect cube, right? So if you can understand the pattern, right? Math is all about pattern. If you know the meaning of square, square means 2 of the same thing, right? Cube, make an intelligent guess. 3 of the same thing. 1 times 1 times 1, 1. 2, 2, 2, 8. 2 times 2 is 4. 4 times 2 is 8. 3, 3, 3, 27. 3 times 3 is 9. 9 times 3 is 27. 3 threes now. All right. Then after that is 4 times 4 times 4 is 64. 5, 5, 5, 1, 2, 5, 6, 6, 6, 2, 1, 6, 7, 7, 7, 3, 4, 3. Watch, show off. I know. All right, I've been teaching all these perfect square and perfect cube numbers, right, since my students are in primary 4. Primary 4, I told them to memorize already. So when they see such numbers, I recognize these numbers, right? They are perfect square, they are perfect cube numbers. And teachers in school, they always use the same numbers, right? If you don't believe, you go and see. These numbers keep popping up one, okay? Okay, so the first thing is the perfect square or perfect cube, okay? Which is usually very common, okay? Sometimes I will talk a little bit, so you all just bear with me, The second situation is something called the what? I call this the first level constant. Okay, first level constant. First level constant means that the increment is the same. All right, the increase or the decrease is the same. Later, I'll show you the example, don't worry. Increase or decrease between terms. All right, increase or decrease between terms are equal. Okay. So first level constant is the one that you have to activate one of the formula which your school will teach. Your school will teach. I hope they will teach. All right. And the third one, this one is crazy. This is called a second level constant. What is second level constant? Don't worry again. Later I will go through. Trust me. All right. That's the purpose here, to teach you something that you never learned in school. Okay. Second level constant, this is going to be super tough. All right. This one is tough. Okay. This one I will show it later. Okay. So let's go and start on something simple first, something like that. 2187, 729, 81, and 27. Can you see not? Like all of them got what? There are some like multiple of 3 involved. You know that? All right. So 27, right? 27 is like what? It's like 3 times 9, correct not? Oh, 81 81 81 got 3, you know? 3 times what? 3 times 27 got Can you see not? So they got the element of 3 inside. They got the multiples of 3 inside. Can I maybe break it down a little bit further? Because when I see 27, right? 27 to me, is a what? Down here. What is this? It's a perfect cube number. So actually for me, I will automatically break it down. All right, 9 can be broken down into 3 and 3 again. All right. So actually, right, 27 can be written as what? 27 can be written as 3 to the power of 3. Is that true? Yes, 27 is a perfect cube number. Then, this 27 here, right? You know, can I do it something? 27 is 3 to the power of 3, right? So it's actually 3 times 3 to the power of 3. All right. So how many 3s are there? All right. Total, there are 3 to the power of 4. There are total of 4 3s. Is that the pattern? Is that a pattern? That looks something like something that we can investigate on, right? So if this is 3 to the power of 3 down here, this is 3 to the power of 4. Can this probably be 3 to the power of 5? I don't know. If that's 3 to the power of 5, maybe is this 3 to the power of 6? Is this 3 to the power of 7? I don't know. Press calculator. Come. So all you got to do is to press what? Press 3 to the power. All right. In your calculator, you see this symbol down here, like that one? The X with the box on top. All right. This is around the center part of your calculator. All right. You must learn how to press your calculator around the center part. All right. So what you do? You press that one first. All right. You press 3. Then you move your arrow to your right. You press to the power of 6. What do you get? 729. Correct, you know. So coincident? Maybe it's just coincident. Better check again. Use your arrow left. All right. Use your arrow left. Press your arrow left twice. All right. In the cursor, right? The cursor will go to your 6 down there. Delete the 6 and put a 7. 3 to the power of 7 is 2187. Very good. Means you're on the right track already. Nothing wrong. Can you see that? All right. So that is the pattern here. 3 to the power 3 followed by 3 to the power 4, 3 to the power 5, 3 to the power 6, 3 to the power 7. What is 3 to the power 5? Press your calculator. Don't worry. All right. Press the left arrow to the left twice. The cursor will be on the 7, right? Delete it away. Press 5. Press equal. Down here, immediately 2, 4, 3. Bam, answer. All right. How about the front one? This one will be 3 to the power what? 4, 3, 2. 3 squared is what? Please, it's not 6. Stop it. Stop it. Don't always have this thinking what? 3 to the power 2 is what? 6. No. 3 to the power 2 means 3 times 3, which is a 9. Correct? Yeah. Please be careful. All right. You're in Sec 1, Sec 2 already. You cannot make all this Primary 5, Primary 6 mistake ever again. Understood? All right. So this is question 1. Nothing difficult yet, right? Nothing, right? All right. So this one is more or less related, a little bit related to the perfect square, perfect cube. So some of the numbers, once you recognize it, you can go and explore a little bit. 27 perfect cube A. Let's go and look through a little bit. Maybe got a pattern out there. And as you can see, down here, the pattern holds. Okay? Okay, moving on.